Yeah, so this is again, so in this session, we will be discussing about the a couple of questions that will help you with doing the weekly assignments. So we are will be discussing the earlier questions in this sessions, and this will help you in doing your weekly assignments that will be published, I think, on Wednesdays. Okay. So shall we get started?
Yes, ma'am.
So actually, since the week, so today I'll be taking the questions from week 1. Okay, so week 1 was basically the introductory session on operating system, right? All of you have gone through the week 1 videos.
Yes, ma'am.
Yeah. So, can somebody quickly summarize what was discussed in the week 1 sessions? Like what is an operating system? What are the components of a system? Have you all understood all that? The major functionality of the kernel or operating system. Aman Kumar, you are telling something?
Yeah, ma'am. Operating system
Yeah.
is a set of collection.
Is it?
Operating system is a set of collection, ma'am.
Mm-hmm.
जी मैम बस
Ma'am,
Set of, yeah.
operating system acts as interface between hardware and the user.
Mm-hmm. Yes, that is correct. Do you all have a laptop? Have a desktop? Have you all
Yes,
used a
yes,
computer?
ma'am.
Okay.
या मैम
You
Yes,
know
ma'am.
which operating system the machine have?
विंडो ऑपरेटिंग
Windows.
सिस्टम
Windows. Any Linux operating system users here?
नो मैम
So this term
No, ma'am.
operating system is not new, right? It's a very familiar term, right?
Yes, ma'am.
Yeah, so this actually facilitates us, the users, to use the computer, right? A computer is basically an electronic device or a hardware. So when I or you, some user wants to use it, we will not be able to directly interact with the hardware. You know why? Why is it difficult to directly interact with the hardware?
No idea, ma'am.
Because machines understand only electrical signals, that is zeros and ones, right? So
या
if
मैम
you have
बाइनरी
to
नंबर
interact, yeah, binary. So if we have to interact directly with the underlying hardware, we need to talk to them in what language they understand. So they understand only presence of the signal or absence of a signal, 0 and 1. So it's very difficult for us human beings to talk to the machine in that language, and that is why we have this whole layer of abstraction, like to the device drivers communicate, operating system communicates with the driver, and we, the users, communicate to the operating system. So, end of the day, I will be communicating to the underlying device only, but via the OS driver and then the device, right? Okay. That is one thing. So that comes like a very basic introduction to operating system. Now, what were the other topics discussed in the session?
Structure of computer system.
Mm-hmm. Yeah, then we'll quickly go through because this in this session I don't have much problems to discuss as this is the introductory week, right? So its assignment is also simple MCQ questions only. So we'll get to that in some time. As you progress, as the lecture progress, numericals will come. That time, yeah, we'll be directly jumping into the problem solving with a short summary. So maybe we can quickly summarize the topics and then go to the MCQ questions. Okay. So components of a computer system, yeah, was discussed. So what are all the components in a computer system? We have hardware, uh, then we have
Hardware,
operating system,
operating
and,
system,
mm,
application programs, and
and then
users. Users.
yes, yeah. So then you know what the operating system do, right? So it controls the hardware and coordinates its use among the various application program that we users write or use. Correct?
Yes, ma'am.
Yeah. So there are two kind of computers,
Viewpoints.
right? From a user's perspective, we can
System
see it
perspective.
as a single user computer or a multi-user
Mm.
computer. So a single user computer is typically like our desktop or laptop, and multi-user computers are like servers wherein many people log in and they simultaneously use the resources of that server. Multiple users will be using that at the same time. Then what else was discussed in the class? So,
Organization of computer system.
mhm. Okay, in that, what was discussed? Okay, computer system organization. Okay. So typically, normal computer system consists of one or more number of CPU, and there will be many devices connected to the computer, and accordingly, we will have many device controllers talk to those devices also. Okay. So these device drivers, which actually does the final job of communicating with the device. And then what does CPU do? CPU does all kinds of operations that we want to execute, right? Like if you want to run a particular program that will add two numbers, the CPU takes care of this arithmetic operation, taking the input. For example, if you write a simple program to add two numbers, okay, which takes the input from your keyboard. Okay, so keyboard will be the hardware. There will be a device controller responsible for transferring the inputted value. For example, if you run the program and if you're giving the number as 2 and 4, this number that you give as input, 2 and 4, has to go to the CPU, right? So that happens via the device control. Then the CPU will compute, do the operation, and then it will be displayed on the screen. The output will be displayed, right?
Yes, ma'am.
Yeah, so even in every small things that we use this computer to use, these all these concepts that you are learning today or that have been discussed in the previous week comes in, right? Yeah, so next, what was the topic discussed?
Computer startup.
Okay, so how does a computer start up?
Actually, a bootstrap program is loaded at reboot,
Mm-hmm.
and when system resets, uh, the program counter in the PC gives a specific value, and the
Mm-hmm.
contents in program counter are loaded in address bus and then in CPU, and then the program will be executed.
Mm-hmm. Okay. So Bootstrap program is the program that takes care of loading the operating system when the system powers up, right?
Yes, ma'am.
So then the next was so so what is an interrupt? Sir have discussed about interrupts also in the previous week, right?
A trap around
And
exception.
One of you please unmute and speak.
It's an
Interrupts are
exception, ma'am.
Okay. So you all are aware of interrupts. Good. Mm.
Ma'am, I have a doubt, ma'am.
Hmm? Yeah.
Ma'am, does interrupts are loaded in OS kernel, ma'am? They are in the kernel mode.
Yeah.
Okay, ma'am.
They are in the kernel.
ma'am, I'm not quite aware of the kernel concept. Can you explain, ma'am?
Kernel is nothing but the operating system program that will be always running. So when you boot up your desktop or laptop, right? So you have this operating system kernel program, or we call it interchangeably, like kernel and operating system. These are interchangeably used in general. So this particular program is always running there, so that any point of time you can go and do whatever task you want to do on the computer. So operating system facilitates us to do all, to use the laptop or the desktop to run various things, execute our programs and all, right? So because it is facilitating it, it is always running there.
So, is there a difference between kernel and OS?
Kernel and
Operating system.
no, that's what it is, an interchangeable term. But commonly we use the term operating system. Okay,
Okay, ma'am.
right. There, then right. So there was also some discussion about the storage and storage hierarchy and all that. So what are the different types of storage available in a computer?
Ma'am, do you mean the devices?
Sorry, do you?
Mean about the devices, memory devices, or like what exactly?
Yeah, so I mean, when we talk about a computer system, majorly we have main memory, secondary memory, and the cache, right?
Yes, ma'am.
Yeah, so that's what I was referring to. Okay, Janvi, you have raised your hand.
Yes, ma'am. Can you please explain me about interrupt timeline diagram? Have
Interrupt.
interrupt timeline diagram.
Yeah, so interrupt. When interrupt in generally interrupts happen when a particular input output operation or certain hardware related tasks are done, and when the device want to inform the CPU that okay, the task is done. Okay, that is when it uses interrupt. So, in the interrupt timeline diagram that Sir had, so you can see that the user program is executing until the IO transfer is completed. Okay, when the IO transfer is completed, the interrupt is raised, and so the user program execution will be halted for a short period of time to serve the interrupt. Then again, that's why you see a short dip in the in like downward square curve, right? Which is very narrow, wide. That time is the time taken to service the interrupt. Then it comes back and then start executing the user program again. In the bottom IO device diagram, if you see that initially the IO device was in idle state, then it
Ma'am, you
starts
are
trans.
talking.
Hello, hello. I'm actually referring to the slide that sir have used. You all have the slides with you, right? Yes, sir. No. Hello. Hello.
Yes, ma'am.
You all have the slides, right? You can download the slides, right? You did not try that.
मैम रिपीट करो मैम क्या बोल रखा आपने
Hello, ma'am.
Hello. So I was not audible in the middle. Hello.
Ma'am, you are audible. Go ahead.
Okay. So I am referring to slide number 21, which is shared in the NPTEL site. Week 1 slide, it is shared in the under the course actually. So I'm referring to that slide here. Let me share my screen. Is the screen visible?
Yes, ma'am.
Yeah, so I'm referring to this particular diagram. This is the interrupt timeline that sir had discussed, right? Yeah, so you can see here that when the IO request transfer is happening, this user program execution is also happening. Okay, so when the transfer is done, the IO device raise an interrupt, and on receiving the interrupt, CPU will halt the user program executing. It will halt or stop executing the user program. It will go process the interrupt. We called the interrupt service routine. It will process that and then it come back and then again continue executing the program. Now again, when the IO transfer is done, you can again see that the interrupt is raised, which makes the CPU halt the user program execution, then serve the interrupt, and then once the interrupt is serviced, it again goes back to the execution state. Okay.
Thank you, ma'am.
I What else was discussed? Solar. Then I think the last topic was storage hierarchy, right? Okay, DN multi-core, dual core. Okay.
Ma'am,
Yeah. Yes.
ma'am, what does number represents
What does
in vector table?
interrupt vector
Vector table
routine?
is a processor event vector table. Vector number, ma'am.
It is there in the slide.
After the interrupt timeline is the same.
Okay. This number is to identify the interrupt. Okay.
Does it show the value of the interrupt or address of the interrupt?
And this will be the value. Then ISR will have the so this is for user purpose, okay, for us to understand. Like interrupt number 0 is for divide error. So it typically in a interrupt vector routine, we will have the interrupt and its address where the code for the interrupt service routine is placed. So based on the incoming interrupt from the interrupt number, this corresponding interrupt service routine will be invoked. So it will go jump to that particular address and then it will be handled.
Okay.
Okay, so I think we can start discussing the MCQ questions.
Yes,
I'll put up like since it is MCQ, I'll put it up as a poll. You can answer them and then probably we can discuss.
okay, ma'am.
Okay. Yeah. Just give me 2 minutes. I'll add the poll now. Is the ball visible?
No, ma'am.
Okay. Is it now visible?
Yes, ma'am.
Yeah, you can give the answer.
No, ma'am.
Ball
It's
is
not
not visible.
Ma'am, can you share your screen?
Ma'am, I'm not. Yes, ma'am, I'm not. Is
Not visible. Unable to get the notification. Let me do it again. Just give me 2 minutes. I'll do it again.
Okay, ma'am.
Is it visible?
No, ma'am.
Yes, ma'am.
It is visible. Yes or no?
No, ma'am.
Okay, but I am able to see the volume.
Yes, ma'am. It's visible now.
It's
No,
visible.
ma'am.
Okay, then. Huh? So can you give the answer in the poll itself?
मैम फिर से डाल दो क्वेश्चन, मैम देख नहीं रहा था उस टाइम।
What?
मैम रिपीट कर दो क्वेश्चन, दिख नहीं रहा मैम। उस टाइम दिख नहीं रहा था तो लीव करके मैंने फिर से ज्वाइन किया मैम।
Cha.
जी मैम।
So the question is, which of the following is not proof for bootstrap program? Probably type the question in the chat. It's visible to everybody, right? The question.
Yes, ma'am.
Yeah, so what is the answer for this question? Which of the following is not proof for Bootstrap program? So is Bootstrap program invoked at power up or reboot?
Yes, ma'am.
All of you can type your answer in the chat. Sorry.
Chat.
You can type the answer in the chat where I have posted the query. Sorry. I don't know. I mean, are you all not able to see the question in the chat?
Now it's
It is visible?
now it's
Yes, ma'am.
Okay.
It's visible.
Okay. You can share the answer also here.
Ma'am, is this user management? Option D.
Well, yeah. Let's come to the answer. Probably we can wait for 2 more minutes so that others can also type their answers.
Okay, ma'am.
Okay, so let's come to the question. So for MCQs, it's very important that you read the question correctly. So does the bootstrap reside in Rome/ePro?
Yes, ma'am.
Others?
Yeah, ma'am. Second one is correct answer.
So second one is not the correct answer because this is
Yeah.
true. The question asks which is not true for bootstrap program. So it's very important you read the question very carefully for MCQs. Okay. So which is not true for bootstrap program? What is the purpose of bootstrap program? So that is the first program that is executed on Power Up, right? So option A is true for bootstrap program. It resides in Romba EEPROM is also true. And then it performs the system initialization, then copies a part of copies the operating system from to the memory, and then from there the operating system takes over. So C is also correct. Performs user management is what is wrong. So Bootstrap program does not do user management. Okay. And the question is, which of the following is not true for Bootstrap program? So answer is D. Okay.
Okay, ma'am.
So when you are attempting MCQs, this is very important. Always read the question carefully. Okay. One last time I'll try Paul. If that also doesn't work, we'll switch to this. Is the poll visible?
No, ma'am.
No, ma'am.
No, ma'am. Yes, ma'am. It's visible.
For those who can see the poll, please record the answer. Can you please choose one of the option and submit the answer?
मैम क्वेश्चन विजिबल नहीं है मैम.
In the poll it is not visible.
No, ma'am.
Okay, for those of you who can see the poll, please answer there. Others, I'll copy paste the question here in the chat as well.
मैम
I have ended the poll.
मैम प्लीज रिपीट द क्वेश्चन मैम.
Yeah.
मैम बोल दो क्वेश्चन. दिख नहीं रहा है मैम कुछ भी. So
Yeah,
नहीं
yeah,
करना
and
है.
I'll do that. Wait, I'll do that. I'll copy paste.
Okay, ma'am.
So for many of the students, the poll was visible and they have submitted as the answer as well. So this is the question. System calls are executed in user mode, kernel mode, both user and kernel mode, none of the above. You can type in your answer here.
मैम फिर से रिपीट करो. स्लोली थोड़ा रिपीट करना मैम क्वेश्चन.
You can
आवाज
see
ब्रेक
the
हो जा रहा है
question in the
मैम.
chat, right? Question you can see in the chat, no? From which device have you joined? It's a laptop or a mobile phone?
मैम लैपटॉप.
So you can go to the chat. It will be visible there.
नो मैम. नॉट विजुअल मैम. I can send your proof, ma'am. Not visible.
So how many of you have joined using the browser? So did you all join using Teams app or via browser?
Browser, I connect the browser.
Anybody else who have joined from the browser? No, I just wanted to see if it is because of browser that he's not able to see the chat. Can anyone of you confirm, please?
मैम स्क्रीन अगर आप बोलो तो स्क्रीन शेयर करके भी दिखा दूंगा, क्वेश्चन विजिबल ही नहीं मैम।
Okay, I will repeat the question. System calls are executed in option A, user mode, option B, kernel mode, option C, both user and kernel mode, and option D, none of the other options.
Kernel mode में
यूजर एंड कर्नल मोड मैम, सी।
So the
Use
answer
and
is
kernel mode, ma'am.
only kernel mode. Okay, system calls are privileged uh, functions or calls that are executed only in the kernel mode. So this is also known as software interrupt. So when a user wants to exit, when like from a user program, when I am trying to do a print, okay, say, take a simple C program or a Python program, wherein you have a print statement, hello world or something like that. Okay, so what happens is this printing has to happen on an input output device, right? Print has to come on your console, right? So what happens is when this print statement is used in the Python language or in the printf is used in the C, it internally does the system call to the operating system, which will then interact with the driver and then do the display of the hello world. Okay. So system call is something that we users invoke from the user space so that privileged executions can be done in the kernel side. Okay, so system call is always executed in the kernel mode. It's not executed in the user mode. Is that clear?
Okay, ma'am.
So system call is like a API that the operating system gives to users for achieving certain tasks from the operating system. Okay, so it's always executed in the kernel mode.
मैम I have a doubt. मैम वीक 1 का असाइनमेंट में एक क्वेश्चन था, which of the following is not appropriate for SSD?
वो week 1 assignment submission is done.
Yes ma'am.
Yes, ma'am.
Okay. Your
But मैम
voice
उसमें
was
मल्टीपल
breaking. हाँ, go ahead. Priyanshu, I can hear you.
मैम उसमें मल्टीपल ऑप्शन करेक्ट है आई थिंक।
So what was the
No,
question?
Which of the following is not appropriate for SSD?
Okay,
Option
options.
A, slower than magnetic disk. Option B,
Okay.
volatile memory.
Mhm.
Option C, contains the hidden magnetic hard disk and a battery for backup power. Option D,
Mhm.
it stores persistent data on a solid state flash memory. Option E, costlier than cache memory.
Okay. What was the question? Which of the following is?
Not appropriate for SSD.
Not appropriate for SSD. Okay, so you had the option to choose only one answer.
Yes, ma'am.
Okay.
I think there is an option about volatile memory. I think
Yeah, I've not
in the
seen the
option.
question. Let me just
But ma'am, last option is also correct.
1 second. So week 2 ka assignment is posted.
No, ma'am. This was week 1 assignment.
So the deadline is over, right?
उसका डेडलाइन 8 अगस्त तक है शायद.
I'm asking about week 1 deadline.
यस मैम, उसका मतलब असाइनमेंट सबमिशन हो गया है मैम, बट इस क्वेश्चन में डाउट था. ऑप्शन बी और ऐसे ऑप्शन बी को मार्क कर दिए, बट ये इस क्वेश्चन में डाउट था. इसमें मल्टीपल ऑप्शंस करेक्ट है और एक ही चॉइस करना है.
Probably you can post this query in the discussion forum. Okay. You have we have a discussion forum, right? There is
मैम
a
लिंक
ask a question when you log in, right? If you go to the course, there will be a tab there, ask a question.
यस मैम.
So there you can post this.
ओके मैम.
Okay. So the respective TAs who's working with the faculty, the professor who is taking the session will respond back. Okay, so this is the yeah, this is where there is this tab, right? Ask a question. Can you see that?
यस मैम.
See, week 1 assignment due date is 9th of August. Right.
Yes, ma'am.
Then I cannot discuss this. I'm so sorry. You should not ask the running assignment question. Luckily, I did not give the answer. Please don't do this, okay? We should not be discussing the running assignment questions. The assignments that are live. Okay. But all your queries regarding the question, any confusion that you have, you can always post in the discussion forum. Okay.
Okay, ma'am.
Yeah. So let's go to the next question. I'll directly copy paste it in the chat. Yeah, is this question visible to all?
No, ma'am.
नो मैम.
No, Paul. I have just posted it in the chat. Just check once.
Option A.
मैम क्वेश्चन विजिबल ही नहीं है।
The question is, which of the following is true as one proceeds higher up in the storage hierarchy? I'll repeat. Which of the following is true as one proceeds higher up in the storage hierarchy? Capacity decreases, speed increase. That is option 1. Option 2 is capacity increase, speed decrease. Option C is capacity increase and speed increase. Option D is capacity increase, speed decrease. Is the question clear?
Yes, ma'am. Ma'am, capacity decrease and
Answer is
speed
option
increase.
A. Option
Yeah, so the correct answer is option A. So as we go up the storage hierarchy, in the top we have cache memory, then we have main memory. Below that we have secondary storage, then we have ternary storage, right? So if you see the hierarchy, top we have the cache memory, and cache is much smaller compared to the main memory, but cache is much more faster than the main memory. So on top of cache, we can even think of registers as the sitting on topmost. So if you see, registers are even more less in number, smaller in size, and they are much faster than the cache. So as we go up the hierarchy, the capacity decreases, but the speed increase. Is that clear?
yes, ma'am.
So let's go to the next question. Okay. The next question is, single user computers, option A, can be used by one user at a time. B, designed for ease of use. C, optimized for good performance. D, all of the other options.
All of the other options.
All of the other option. All of the option D is correct.
So what is the other type of computer? One is single user computer. What is the other type of computer that is available?
Multi-user.
A mainframe computer, supercomputers,
Mm-hmm.
Multi-user.
Okay. So in what way is single multi-user computer differ from single user? What are the characteristics of multi-user computers?
it is connected to network like in a peer-to-peer network.
For resource utilization.
Okay, so the answer is D only. Single user computer can be used by one user at a time. It is designed for ease of use, optimized for good performance also. Okay, so I think everyone is very clear with this. The next question. So I have added a poll. Those who are able to see the poll, please respond. Can someone tell if you're able to see the poll?
Yes, ma'am.
Miss, it's visible.
Yeah, please respond there. I'll stop it in maybe a minute or so. So I'll copy paste the question for others also. Here in the chat. Yes, so the question is resource utilization optimization is a goal for option A, single user system, B, multi-user system, C, both single and multi-user system, and D, none of the other options. So resource utilization is a
Ma'am,
goal for, yeah. Yes, go ahead.
nothing, ma'am.
Okay. So this resource utilization is a goal for a multi-user system because when a system is utilized by multiple people, the main goal is that all the users should get fair share of the resources, right? It should not be like the system, the resources are given in a partial manner. Like only one user is given like 90% of the time the CPU. Rest of the users are given only 5% or 10% of the CPU. That should not happen, right? So all the users who are using the system should be able to use it in a fair manner. So to ensure that resource utilization is the major goal for a multi-user system. It has to be properly utilized also, like fair share plus the resource sharing. I think you will learn much about resource sharing and all in the upcoming week lectures actually. We'll go to the next question.
Ma'am?
Yeah.
Is single user computer systems, do they have resource utilization as a goal for them?
Well, there is no need of it, right? Only one person is using. So the whole resources are available for this one person only, no? So there is no sharing here, right? Okay. In the other scenario, there is sharing of resources, right?
Yes.
But ma'am, in single user system, there can be a multiple process running simultaneously, ma'am. Then resource utilization.
That will be taken care, yes. That will be taken care. But within the particular user, yeah, that will be taken care. But this is with respect to when multiple users are simultaneously logging in and utilizing. So there is these concepts of resource sharing that comes in the operating system. Okay. So there all these concepts will be discussed and explained. Okay. It will be handled in the upcoming week lectures. So as of now, just have these notions in your mind. These concepts are going to come in the upcoming sessions.
Okay, ma'am.
So I've posted the next question.
Hello, good evening, students. ये जो internet
Ma'am, question is not visible, ma'am.
Ma'am, option C.
I'll read out the question maybe in some time. Okay, so the question is from the point of view of the computer, its operating system is option A, resource allocator, option B, control program, Option C, both resource allocator and control program. Option D, neither resource allocator nor control program. So I'll repeat the question once again. From the point of view of the computer, its operating system is A, resource allocator, B, control program, C, both resource allocator and control program, D, neither resource allocator nor control program. So those who could not see the question can now type the answer.
Option C, ma'am.
Okay, so this I think pretty much everybody got the answer correct. Yeah, all of you got the answer correct. It is C, it is a resource allocator as well as a control program. Okay, so that is clear. Now let's go to the next question. Sorry?
Is a control program that like of a processor?
Control program which will control all the other user programs, other users and all that.
So it's also done by the OS, right? And the processor too, right?
Sorry?
The processor also does that, right?
No, processor does not do that. Processor does not do. The CPU only executes the instruction. So which process has to be executed, and at what time, how long, all these things are decided by the operating system. CPU does not do controlling.
Okay, ma'am.
You meant CPU, right? Processor CPU, right?
Yes.
Go to the next question. Is it visible?
Yes, ma'am. Answer is A, ma'am.
Mhm. For those who are not able to see the question, I'll read it out. Okay. So the question is, the first process in Unix is A, init, B, boot, C, start, and D, none of the other option. I repeat the question. The first process in Unix is A, init, B, boot, C, start, and D, none of the other option.
Option A, ma'am.
Okay, so here again, I think all of you have answered A only. So the first process that gets created in Unix is init. So the next question. Is the question visible?
Yes, ma'am.
No,
Yes,
ma'am.
ma'am.
You
It's
can
B,
type in
ma'am.
the answer. You can type in the answer.
Ma'am, question is not visible, ma'am.
Yeah, I'll read it out. Um, So the question is, system calls are invoked via option A, call to procedure, option B, software interrupt, option C, hardware interrupts, and option D, none of the other option. I repeat the question. System calls are invoked via A, call to procedure, B, software interrupt, C, hardware interrupts, and D, none of the other option. Yeah, so the answer is B, software interrupt. Okay. The system calls are invoked via software interrupts. I think we had a discussion on system calls earlier, right? Yeah, so let's go to the next question. Put this question in poll as well, so I'll have some records. So those who are able to see the poll, please answer via the poll. Those of you who are able to see the poll, please answer via that.
I'm C.
Yeah, I'll just post it in the chat also so that others who have not, who could not see the poll can also answer. So I have posted in the chat the question. The question is, interrupt vector contains list of interrupts available in the system. List of interrupts occurred at a point, address of interrupt service routine, return address on occurrence of interrupt. I'll repeat the question. Huh? Repeat the question. Interrupt vector contains list of interrupts. Option A, list of interrupts available in the system. Option B, list of interrupts. Option B, list of interrupts occurred at a point. Option C, address of interrupt service routine. And option D, return address on occurrence of interrupt. So the answer here is address of interrupt service routine. So interrupt vector table actually contains the address of the interrupt service routine or ISR. Okay. So that when an interrupt occur, the service routine can be what to say the program counter can be set to the ISR address, and then the interrupt service routine can be executed. So vector table contains the address of interrupt service routine. Okay. So we'll go to the next question. I'll add it as a poll. Those who are able to see the poll, please answer there.
Ma'am, not visible, ma'am.
I have just now posted it.
Yes, ma'am. It's
Yeah, yeah. So actually, in the chat, you should be able to see the poll. I don't know why many of you are not able to see. Okay, this time I got 6 response. Good. So the question is, the size of a word in a computer system is 8 bits. Option A 8 bits, option B 16 bits, option C 32 bits, and option D dependent on the system. I repeat the question. The size of a word in a computer system is option A 8 bits, option B 16 bits, option C 32 bits, and option D dependent on the system. So the answer here is option D, dependent on the system. So it's not fixed that word is 16 bits or 8 bits or 32 bits. Okay. So word can be 32-bit word. So on some computers, it can be 32 bits wide. On some computers, it can be 64 bits wide. On some, it can be 16 bits wide. So it's dependent on the system. Okay. So we'll go to the next question. Again, those who can see the poll, please respond there. So I have launched the poll. So those who can view the poll, please answer it. So the question is direct memory access transfers data between option A, CPU and main memory, option B, CPU and secondary memory, option C, main and secondary memory, and option D, none of the other options. So I repeat the question. Direct memory access transfers data between CPU and main memory, CPU and secondary memory, main and secondary memory, none of the other options. So here in the poll also I've got a mixed response for all the options. Just end the poll. Okay, so for the nine responses. So what is the answer? What is direct memory access?
It does not involve CPU for the memory access between
Mhm.
memory and input-output devices.
Okay. So, yeah, so the option A and B is crossed off, right? Because it does not involve CPU. So direct memory access, or take it this way, if one want to transfer data between CPU and main memory, then CPU has to be involved, right? The same way CPU and secondary memory. So DMA is used, the option given as C, main memory and secondary memory, because we can use DMA for transferring data between main memory and secondary memory as well without involving the CPU. The highlight with DMA is that it when this memory transfers are happening, we are not actually wasting the valuable CPU cycles, or we're not making the CPU wait for these memory transfers. So typically memory operations or memory transfers between IO devices or secondary storage is considered as time consuming because those devices are slow. Okay, so when if we are involving CPU for all these, CPU will be literally waiting for these operations to get over. So it's equivalent of wasting the CPU cycles, which otherwise could have been used for actual processing work. Okay. So the concept of TMA is to remove the CPU away, keep the CPU away when these memory transfers are, when the data is getting transferred between memory. And so that when I say keep the CPU away means CPU can do other task during that time. Is that clear?
Ma'am, but transfer of data is done between memory and input-output devices, no, ma'am.
We can do it between IO and memory, between secondary storage and memory. All that is possible. Okay.
Okay, ma'am. Thank
It's
you.
not like it has to be only IO.
Okay, ma'am.
It's not like it has to be like only input output device. No, can be between the main and secondary memory as well.
The only access is CPU. CPU should not be used.
Yeah, CPU will not be involved in between. DMA
Okay, ma'am.
controller will take care of this. Yeah. Let's go to the next question. Typically, 2 more or 3 more. Just put it as on the So all those who can see the poll, please respond there. For others, I have posted the query in the question in the chat. You can respond here in the chat. Okay, so the question is between L1 and L2 cache, which one is private to the CPU core? I repeat the question, between L1 and L2 cache, which one is private to the CPU core? Option A, L1, option 2, L2, option 3, both L1 and L2, and option 4, neither L1 nor L2. So I repeat the question once again. Between L1 and L2 cache, which one is private to the CPU core? Option A, L1, option B, L2, option C, both L1 and L2, and option D, L1, neither L1 nor L2. So pretty much I think everybody is aware of this answer. So the answer is L1. That is, yeah. So when we have a multi-core CPU architecture, there is this L1 cache which is private to each core, and there is another L2 cache which is common between the cores, right?
Yes, ma'am.
That answer was pretty clear. Everyone. Okay, we'll go to the next question now. Second last. Okay. So I have launched the poll. Those who are able to see that, please answer there. The benefit of others, I'm posting the question in the chat. Okay, so the question is device drivers for devices are generally developed by option A, operating system designers, option B, device manufacturers, option C, system programmers, and option D, application programmers. I repeat the question. Device drivers for devices are generally developed by option A, operating system designers, option B, device manufacturers, option C, system programmers, and option D, application programmers. So the answer here is device manufacturers. Okay. So device drivers are developed by the device manufacturers because it is only they know how the what is the how the hardware works and all that. So it is done by the device manufacturers. Okay. So this is the oh, this is the second last.
Ma'am, is
Mm,
L2
yeah.
cache, ma'am, is L2 cache
Ah,
private to the processor or it is shared between all the processors?
See, nowadays, how it happens is there will be a processor unit which will have multiple cores in it. Okay. CPU core 0, CPU core 1, CPU core 2 करके there will be n cores for a particular processor. Okay. So L1 cache will be private to each core and L2 cache will be common across all these cores.
No, ma'am, I am talking about multiprocessor.
Multiprocessor, right? So L2
Yes, ma'am.
cache will not be common between the multiple processors. No.
There will be L3 cache, ma'am.
That actually, I am not sure. Multiprocessor, the cache layout. Probably I'll check and get back to you in the next class. I'll get back, okay?
Okay.
So I have launched the poll, so you can answer there. For others who cannot see the poll, I have shared the question in the chat. So the question is, which of the following act as cache for the secondary storage? I repeat the question. Which of the following acts as cache for the secondary storage? Option A L1 cache, option 2 L2 cache, option C main memory, and option D tertiary memory. I repeat, which of the following acts as cache for the secondary storage? Option A L1 cache, option B L2 cache, option C main memory, and option D tertiary memory. So the answer here is main memory. Okay. So every higher level memory acts as a cache for the lower level memory. So it is kind of a cache for the lower layer memory. Okay. So for secondary storage, its cache equivalent is main memory because main memory comes above the secondary storage, right? So main memory act as cache for the secondary storage.
Ma'am, what will be the cache for tertiary memory? Tertiary memory?
It will be secondary storage. So in the hierarchy, you can see in the hierarchy. So every the memory which is just above its level will act as cache to the lower level.
What about main memory, ma'am?
For main memory, a cache is there. No? Cache itself acts as the cache. So by
Okay, ma'am.
cache, we mean that the frequently used, the recently used, the commonly used things that are stored for faster access. So the last question. Yes, I'm not putting a poll this time. All of you can answer here in the chat. So the question is, handheld computer systems are optimized for option A, computation, option B, battery life, option C, resource utilization, and option D, none of the other option. I repeat the question. Handheld computer systems are optimized for option A, computation, option B, battery life, option C, resource utilization, and option D, none of the other option.
Battery life.
So,
Battery life.
yeah, so the answer is battery life. Okay. So So any queries or any doubts other than the cache doubt that one of the student asked on multiprocessor, how the cache layout is? Any other queries you have?
No, ma'am.
Okay, so yeah, so let's close today's session. Yeah, we have 3 more minutes. So in the next class, next week, again, Tuesday, 6 to 8, we will be having, I'll be taking this session, interactive session. So we can discuss the topics discussed by Professor for week. And then correspondingly, I'll come up with some earlier assignment questions related to those topics discussed. We can discuss the questions like this. If it is MCQ, probably we can discuss like this. If they are numericals, then we can try to solve. Okay. Yeah, so thank you all for joining the session. Thank you. See you next week.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Yeah, thank you.